As the world's leader in pyrolysis technology, International Environmental Solutions Corporation's advanced pyrolytic system is being acknowledged as one of the most viable, air quality permitted, and environmentally acceptable technology solutions commercially available today for transforming waste to energy. Pyrolysis, unlike incineration, allows for the thermal destruction of waste in an oxygen-free atmosphere, virtually eliminating all harmful and toxic substances, at the same time providing an effective method for reducing landfill volume by up to 92%. This allows for the complete destruction of environmentally harmful waste materials, while producing valuable byproducts and generating environmentally clean and profitable electrical power. Our system has been approved by federal, state, and local agencies in the USA for air quality, and exceeds all EPA environmental regulations and guidelines. International Environmental Solutions has the capability of designing and constructing a turnkey waste-to-energy facility. With its modular-style design, IES custom engineers a plant to fit the needs of the customer, based on waste disposal requirements as well as energy output needs, whether utilizing the steam for process needs or heating, or for cogeneration to produce clean, renewable power. This plant is designed to handle 1,000 tons of waste per day, utilizing 4 complete lines. Each of the processing lines has a minimum capacity of 250 tons per day, approximately 10.5 tons per hour. Designed for trouble-free operation with a limited number of operating personnel and minimal downtime, our exclusive safety features control temperature and process flow at every stage, while automatic shutdown safety mechanisms provide for total staff, system, and environmental safety. The waste material is delivered to the plant, is weighed, and begins the process as it enters the recycling facility before being transformed by pyrolysis, where it exits the process as clean carbon char and electrical power. After being placed in the storage staging area, the material is transported by front loader to the feedstock material handling system, then placed on a feed conveyor, which moves the waste to the pre-processing stage. This consists of a sort line, magnetic separator, shredder, dryer, conveying and final feed system. The waste material proceeds down the processing line on a sorting conveyor, allowing the manual and automatic removal of items to be excluded from the pyrolytic process. The diverted material discharge chutes ensure the prohibited products are collected and remain sorted with like materials for eventual recycling, like aluminum and glass. The material then passes through the cross-belt magnetic separator, allowing for constant automatic removal of ferrous metals for recycling and diversion from the process stream. This system allows for the discharged ferrous items and other sorted materials to be easily collected for revenue generation by recycling. After the sorting and separation, the remaining material is conveyed into our industrial shredder. This provides a consistent method of process feed material, reducing it to 2 inches or less for maximum material quality input. The material is then moved onto the shredded discharge conveyor and into the rotary dryer, utilizing the pyrolytic waste heat to dry the feed material. This allows the moisture to be reduced from 25% or more to 10% with a single pass through the dryer. The waste material is moved via the dryer discharge conveyor onto the pyrolysis feed conveyor, which moves the material to the pyrolytic thermal converter through a proprietary valve design. This allows the waste material to enter the pyrolytic chamber without the presence of oxygen. Upon entry into the retort portion of the pyrolytic chamber, the waste transverses the length of the retort via a proprietary design. During this process, waste streams are subjected to very high temperatures in the absence of oxygen, which has the effect of reducing the waste to a carbon char residue and a gaseous product. These products are separated via gravity, with the solid carbon char dropping out of the bottom of the pyrolytic chamber and the gaseous product being vented to the entry of the thermal oxidizer. In the thermal oxidizer, the off gases from the pyrolytic chamber are subjected to a high temperature oxidation process. As the now oxidized gases leave the thermal oxidizer, the high temperature, high energy potential of the exiting flue gas is heat exchanged to a waste heat recovery steam generator. The waste heat recovery steam generator captures this useful thermal energy and converts this energy into high-quality steam at 650 degrees Fahrenheit and 750 psi. Finally, the exiting flue gases pass through advanced NOx control and a wet scrubbing system, rendering it completely safe and harmless for permissible emission into the environment. The high-quality main steam generated flows through a common header to the inlet stop valve of the steam turbine generator, which converts it to electrical power for distribution into the municipal electric system. The amount of steam generated is directly related to the energy content of the waste feedstock materials, and power generated from the steam can be between 35 and 60 megawatts depending on design considerations. Even if one unit is out of service, the plant remains operational and continues to process the waste material and generate electricity. If the waste fuel stream is ever interrupted, the thermal oxidizer is engineered in such a way that it can be used similar to a duct firing arrangement to supplement the heat needed to maintain steam generation necessary for guaranteed power supply contracts. The powerhouse and substation yard contains all generation and utility interconnect components consisting of dedicated steam turbine generators sets, which include control systems, cooling systems, circuit breakers, utility paralleling switchgear, generator step-up transformers, and electrical substation and towers, where the electricity generated is distributed to the utility grid. Should black start capability ever be necessary, 4 2-megawatt diesel engine standby generator sets are located next to the power island in the event of a central utility company failure. This entire waste-to-energy plant and pyrolytic system is controlled by a state-of-the-art electronic control package, providing a single, simple point for operator interface, control and monitoring, controlling startup and shutdown. Emergency shutdown capability is provided automatically and also at points adjacent to the individual machinery sections. The heart of the ECP system is based upon dual redundant controllers with Ethernet interface, which maximizes performance with a minimum of operator interference. Monitoring of the facility and its performance, as well as every part of the advanced pyrolytic system, is possible from anywhere in the world, 24 hours a day, allowing technicians to consult with the manufacturer of components accurately at any time, day or night. The design of the IES system allows for different configurations for a waste-to-energy facility, whether based on capacity, specific waste streams, or energy output needs. Although the standard IES pyrolytic system design uses pipeline natural gas to pyrolyze the waste stream, alternative fuels can be used when natural gas is cost prohibitive or not available. Our technology serves dual purposes by helping to address the growing worldwide problem of waste disposal, while utilizing the waste product to generate clean energy for our surrounding communities. IES, transforming your future from waste to energy.